that I follow when I'm add fractions. I'm asking myself how many times t plus 9 can go to t plus 9 multiplied by t minus 8. So I'll simply divide by t plus 9. So t plus 9 will cancel this t plus 9 because they are common factors. And then I'm left with t minus 8. Here is the t minus 8. Again, when I'm considering the second denominator, which is t minus 8, I am going to divide my LCM by t minus 8. Again, t minus 8 will cancel out the other t minus 8. I'm left with t plus 9. Then now you are going to recall that earlier on I've mentioned that you need to know to remove brackets. So when we are removing brackets, we multiply the outer number inside the bracket. So we are going to have 4 times t, 40. 4 times 8, remember the sign, minus 32. And then plus 5 times t, 5t. 5 times 9, 45. All over t plus 9 multiplied by t minus 8. Remember, we are simplifying expressions. When we are simplifying expressions, it means that we need to have a single fraction. So now I am collecting my like terms. 40 plus 5t, it's going to give me 90. Remember, the term always take the sign in front of it. So I am going to say minus 32 plus 45, which is going to give me 13. And now my final answer is 90 plus 13 all over t plus 9 multiplied by t minus 8. And again, please make sure you remove your brackets nicely. You multiply all the terms inside the brackets by the number outside the bracket. Now I am having another example here whereby I want to simplify this problem when I am having a subtraction. I have 8x plus 5 over 6 minus 5x minus 3 over 7. I am going to look at 6 and 7. I'm finding a number that can be divisible by 6 and also divisible by 7, and that number is 42. Then I call my number 42 as my LCM. Following the same principle, 6 into 42 is 7 times. I multiply it with the numerator, which is 8x plus 5 minus, because of this minus here, minus 7 times into 42, which is 6 times. And then I multiply I remove the brackets and I get this. And then I collect my like terms. Remember, the term always take the sign in front of it. And then now I'm having 42x minus 40, which is going to give me 2x. And 35 plus 24, which is going to give me 59. At the end of the day, I'll have my answer as 2x plus 59 over 42. Lastly, I have this problem. Now the denominator is having 2 terms, 3y minus 1, and also I have the other denominator 5y plus 3. You are going to recall that I have mentioned that if you have your denominator with two terms, you simply make their product, and their product is 3y minus 1 multiplied by 5y plus 3. So following the principles of dealing with fractions, I'm going to look at this as my LCM. Then I divide it by 3y. Remember, I said 3y minus 1. When you are dividing, you just cancel these ones out, and then it means 3y can go only 5y plus 3. Here it's the 5y plus 3. I'm going to multiply it with the numerator up here, and then I have 5y here we are going to get 3y minus 3y. If I have 3y minus 1 multiplied by 5y plus 3, all dividing by 5y plus 3. So it means I'm going to cancel out this one and I get 3y minus 1. And then I follow the rules of removing brackets. 5 into this one, I multiply 5 by 7 to get 35. 7 times 3, 21, minus, remember subtract, if you have a minus sign outside the brackets, you are going to change the sign inside the bracket. So I'm going to have 12y. Take note of that. Negative 4 times 1 plus 4. So this is very important to note that your bracket is having a number which is negative or positive outside. And then I simplify my problem to be this one. What is going to happen if I am now multiplying or dividing fractions which involve an algebraic fraction? So when we are multiplying fractions, you just multiply the numerators and also multiply the denominators together. I have an example here where I have a over b multiplied by c over d. A is our numerator, b is our denominator. So if I'm going to multiply my numerators and then multiply my denominators, I'm going to say a times c, which is going to give me ac, b times d, which is bd. It is now in its simplest form because there are no common factors. I have another one here, 3 over a multiplied by 5 over a. 3 times 5, we get 15. A times a is going to be a squared. And then your answer is final because it's left in its simplest form. But it is going to happen that you have some common factors. If you do have some common factors, please cancel common factors before you multiply. So now I'm having 8 over 9x times 27 over 4x. So I'm going to say 9. I'm going to look my numerators and also my denominators to see if they do have a common factors. If they do, I'm going to cancel them out first before I simplify any further. So 9x, it's going to be x here and here 3 times, and then 8, it's going to be 2 times here, and then I have an x here. Then now I'm left with 2 times 3. 2 times 3 is going to give you 6. X times x, which is x squared. So our answer is in its simplest form. When you are dividing a algebraic fraction, what is going to happen? Remember, when dividing by a fraction, it's the same as multiplying by its reciprocal. When you are dividing by a fraction, it's the same as you are multiplying with its reciprocal. So I have a over b divided by c over d. So this means that I'm going to make c over d its reciprocal. What is the reciprocal of c over d? The reciprocal of c over d is going to be d over c. So when we are making a reciprocal, you take what was a numerator to be a denominator, what is a denominator to be a numerator. So now I am having a over b. Because I have made my reciprocal, I am going to multiply. I was dividing, so now I'm multiplying because I have changed the other fraction to be in its reciprocal. So I am having a over b multiplied by d over c. A times d, ad. B times c, bc. And my final answer is ad over bc. I have another example here when I'm dividing by a decimal by a fraction. by a fraction. I have 2 over 3x divided by 4 over 5x. Remember, dividing by a fraction is the same as multiplying by its reciprocal. So we look at the next fraction, which is 4 over 5x. 4 over 5x, its reciprocal is going to be 5x. We take what was a denominator to be a numerator. So now I'm having 5x over 4. I am going to multiply now because I have its reciprocal here. So it's going to be 2 over 3x multiplied by 5 over 4. Then remember the rules of multiplying fractions. We multiply the numerators together and also the denominators together. Remember, I have mentioned that you need to simplify before you multiply. 2 can go to 2 once, 2 can go to 4 twice, and this x can cancel out this x. I am now left with 1 over 3 multiplied by 5 over 2. Multiplying numerators, 1 times 5 is going to be 5, 3 times 2 is going to be 6. And my answer is in its simplest form, so I'm going to leave it. We have another problem whereby we are solving fractional equations. Fractional equations that arise from an algebraic fraction. Remember, we have defined our algebraic fraction as a fraction that contains an unknown. So when we are having an equation, now we have only one unknown. In this example, in this particular example, the unknown is a. Only a is the unknown. So I'm going to have 3 over 4a equals to 6. My LCM here is 4, because 6 as a fraction is given as 6 over 1. So 1 can go to 4 and 4 can go to 4. So it means our LCM is going to be 4. When you are solving an equation now, you are going to multiply all the terms of the equation by the LCM. All the terms of the equation by an LCM. In this case, we have only 2 terms. So it means I'm going to multiply by 4. I'm going to multiply by 4 again on the other side. And then multiplying by 4 is going to simplify to 3 over 3a. And 6 times 4 is going to be 24. Now you divide 3. You divide by 3 both sides because you are solving an equation. And then you isolate the a. A is equals to 8. The steps, you find the LCM. You find the LCM, that is step number 1. You multiply all the terms by the LCM. You then follow the rules of solving an equation to isolate the term. You follow the rules of solving an equation to isolate the term. Remember, if you have a numerator or a denominator which has more than one term, like I am having here 2m plus 3. 2m plus 3, we have, this is just a numerator with 2 terms. So it means that I am going to put brackets around any numerator that contain more than one term. Here are the brackets. I put brackets and then I multiply by the LCM. What is the LCM of 6 and 2? The LCM is 6. The lowest common multiple of 2 and 6 is 6. Then I'll multiply by 6 both sides. This 6 is going to cancel out. Here I'm going to be left with 3. So I follow the same rules of solving equation, and I have my resulting answer as 18 equals to m. If So that's marked the end of my lesson for today. So what we have learned today, we have learned how to simplify an algebraic equation. We have learned to simplify an algebraic fraction by adding, subtracting, dividing, and also multiplying. We have also solved an equation which arises from an algebraic fraction. And then I wish, dear learner at home, that you do the following exercise. We have this as our exercise or homework. You can copy it down to try it out. We have t minus 1 over 2 plus 4t minus 7 over 3. Here we have some expressions, and this side we have some equations. 15x minus 7 over 4 minus 11x minus 6 over 6. And we have 10x squared over 6 divided by 24x over 15. And yes, we have d 13 over 3y times 6 over 26. Those are the expressions, and then we solve our equations on the other side. And thank you for your time.
Thank you very much, Saneme, for your lesson, and we're hoping that at least they'll be able to at least try to simplify algebraic fractions, I'm sure.
Yes, definitely.
Thank you so much. We're hoping to see you soon, of course.
Thank you. Thank you.
All right. Form 4s, please do not go anywhere. Up next is your chemistry lesson. We'll be right back after this.
This week on Eswatini Lifestyle.
Gentile, the vibes!
The vibes are right.
Yeah. Yeah, these guys can have fun anywhere. Trust me. Anywhere.
Ngiyathi ukuthi lithalenta eSwatini liyenyuka lilanga especially ku-comedy sector.
Wonke sonke lesikole nangithi ngifaka lona sikhathi ugcina nje thola staptini uyangiva ukuthi
Sinabo small, sinabo gogo, nabo silwane khiphani mamaski batonive makhaya banive.
Angithi lo moya uyevakala abantu abamlothi awusesuke campaign. Na uthi asithi ukuthi yem.
So ivele isukile masoti labahle.
Tune in to Eswatini TV this Friday at 6:30 p.m.
Why should we pay our TV license?
The content on our local television is actually more up to date. The industry is enhanced.
It is a criminal offense not to pay your TV license and attracts a fine of 500 emalangeni or 6 months imprisonment.
And the industry is definitely blooming, ladies and gentlemen. So that's what we have for you. But we'll be right back just after the break, and we'll give you more of Miss V.
Pay my TV license. That's why I can enjoy the benefits of an enhanced industry and keep track with recent transformation.
Mommy, who paid for a TV license and what are they paying for?
The owners of TV set and a gadget with a tuner like DVD set have to pay.
Pay your TV license at NetBank with the details provided on screen. Or use your cell phone via the mobile money pay. You could also visit your nearest post office and pay there. Pay your TV license via Eswatini Mobile Imali. Any TV device retailer can purchase a license to trade. Pay your TV license and enhance the industry.
A very warm welcome back to our viewers and a very good afternoon to the Form 4s who have just joined us. We are doing chemistry right now with Tobile Mahengela, who is already with me in the studio. My name is Nogwazi Dlamini and this is Home Study on Eswatini TV. How are you doing this afternoon?
I'm okay, Nogwazi. How are you, sis?
I'm doing great. Thank you very much. We're doing separation techniques today.
Yes.
What are you expecting your Form 4 learner to have learned by the end of the lesson?
Okay, although this is a longer topic, we'll only just do a short part for today.
Okay.
So by the end of today's lesson, we expect that learners should be able to describe purification methods by use of a suitable solvent.
Okay.
That is to say, filtration, evaporation, as well as crystallization.
Okay, I'm going to pretend I understood what you're talking about.
Hopefully you will.
Yes, okay. The Form 4s, I'm sure they know what you are talking about. Form 4s, we hope that you are ready for your lesson. And of course, a reminder that we are live on YouTube and on Facebook. And if you have any questions, please feel free to use our WhatsApp number. Please, Tobile, you may start your lesson.
Thank you. So, dear learner, as I've said that in today's lesson, we'll only be describing methods of purification by the use of filtration, evaporation, and crystallization. Why is this important? We're saying this is important so that it's necessary to be able to separate substances physically combined. Remember, if a substance is physically combined, it requires physical means to separate. For instance, let us check this. We're saying with this example, you were doing home grinding, right? Trying to get millimil. And then after that, you see that this is not the quality of millimil I'd like to have. So you use a sieve to get rid of the chaff. And then here's scenario number 2 here, whereby this person is trying to, is building. So he wants proper sand, finer sand, so he's getting rid of the smaller stones which may not be of the consistency that he requires. So even here it's an example of using separating techniques. So without much further ado, let us get into our lesson. We'll start with explaining terminology. These will be featuring a lot during our lesson, dear learner. First of all, we'll look at insoluble solid, whereby we say this is a solid that doesn't dissolve in a liquid. A solvent is a liquid into which the solid dissolves. Remember, the solid should be able to dissolve in the solvent. And then solute, which we can also term as soluble solid. This solid that dissolves in a solvent to form a solution. Hence, my learner, we can say that a solution is simply a solute that can dissolve in a solvent. So take note of these terms: insoluble solid, solvent, solute, as well as solution. We'll start off with the first separating technique of the day, which is filtration. This technique, dear learner, is used to separate an insoluble solid from a liquid, for example, sand and water. Filtration depends upon the different sizes of particles in a mixture. The liquid particles are small enough to go through the filter paper pores, whereas the solid particles are too large, dear learner. The liquid, we can term it as a filtrate. This liquid is the one which is able to pass through the filter paper, which is acting as our porous object. The solid will then be left behind on the filter paper as a residue.
Tobile, I'm so sorry to interrupt you there. Could we please just take a little bit of an infomercial break?
Yes.
Viewers at home, we'll be right back after this. Welcome back to our viewers. After that very short infomercial break, Tobile, I think you may please continue with your lesson.
Thank you, Sissy. As we were saying just before the commercial, the liquid which is able to pass through the filter paper is referred to as the filtrate. And then the solid that remains behind on the filter paper is referred to as the residue. Please, dear learner, always remember that when you're describing filtration, we expect you to mention the filtrate, we expect you to mention the filter paper, we expect you to mention the residue. These terms are very important. This is a diagram just to illustrate filtration. This is the basic setup, dear learner, the basic setup as well as the identification of the different apparatus that make up filtration. So here we have a conical flask. Please be careful of the shape. There are many different types of flasks, for instance, distillation flask. So be very specific when talking about this flask. We also have the filter funnel, which we place on top of the conical flask. And then inside, we place a filter paper, which is the object that is actually doing the separation. Once you are doing the mixture, dear learner, what you expect to come through the pores of the filter paper is now the filtrate, which is in a liquid form. And on the filter paper, the residue will be left. It's up to you whether you want to discard of it, but this is now the insoluble solid. Let us do this short exercise. Identify the filtrate, the residue, the filter paper when tea bags are used to make a cup of tea. Now let us look at the response. We are saying the filtrate, remember this is the liquid part, will be the tea which will actually be sipping on. The residue will be the tea leaves. Of course, we don't expect anyone to be chewing on the tea leaves, so most of the time we discard of that. And then the filter paper, this role will be played by the tea bag, which will now be acting as a porous object. Let us now watch a short video to illustrate this type of method. This is filtration, and before we continue with our experiment, always remember to wear the proper gear. We are having a mixture of sand and copper sulfate solution, and before we continue, we have the apparatus, which is the conical flask, the funnel, filter funnel, which we place on top of the flask, and then we're about to put in the filter paper. Remember how to fold the filter paper carefully. Once we finish folding it, we place it in the filter funnel. If it's not in place, then you can simply just add a bit of the liquid just to wet it on the side so that it remains in place. Now, dear learner, to begin our separation, you slowly put in the mixture through the filter paper, and then watch as the filtrate, which is the liquid, comes through the filter paper. This will take quite some time, so I previously prepared this method for you to save time. Please note that what is coming through the filter funnel is now the liquid only. We are not expecting any solid particles to come through because they are trapped inside the filter paper as a residue. Remember, I said use the proper terminology for each type of method. This is now then the results of what had been previously prepared for you. You can see that inside the filter paper, the sand has now remained as a residue, and then we now have a blue solution of copper sulfate, which has passed through as filtrate. Let us then go to the second method of the day. This is evaporation. This is a process by which a substance changes from a liquid to a gaseous state, which we normally call vapor. Therefore, through evaporation, dear learner, we can be able to obtain a solute from a solution. Remember, the solute is the solid. Evaporation is done using an evaporating dish by heating the solution until all, please remember, until all the solvent disappears completely as vapor, leaving the required solid or solute behind. For example, if we want to get salt from a mixture of seawater. This is a diagram to illustrate evaporation. This is another method, so it requires its own setup and its own apparatus. So since we mentioned the importance of heat, we need to have a heat source, and in a lab setting the heat source is the Bunsen burner, dear learner. We also have the tripod stand, although only 2 legs are showing now just because of the angle. It has 3 legs. On top of it we place a wire gauze, on top of which we're going to place our evaporating dish. And then we have our evaporating dish through which we're going to place our mixture. Remember, we are dealing with a solution this time, whereby we do not want the solvent. We are simply interested in the solute. Note, dear learner, evaporation is an example of fast crystallization, which means we also have slow crystallization. Now let us watch a short video to demonstrate evaporation. This is the filtrate which we collected from filtration, which was the method we did previously. And before we continue, we transfer that to the evaporating dish, dear learner. We then place it on top of the wire gauze, which is placed on a tripod stand. You see there are 3 legs there. And then there's a heat source. You will note that the flame was a bit yellow, so that is not the flame we want. So first adjust your flame to have it being a blue color. Now we are performing evaporation, and so we are heating this solution. Remember, in evaporation we are not interested in the solvent, so we want to burn it. We want to heat the solution until all the solvent has escaped. So even in this video it takes quite some time, so I'll just be showing you the steps, but I already have a product which was done the hours before. So you will see when they are zooming in, now the solution is beginning to boil, and you can see a bit of a gas leaving. That is the vapor. Remember, this is copper solution, which means it is made up of copper, salt, as well as water. Before we remove the evaporating dish, be very careful that you use laboratory etiquette. If you are to pick something or touch hot objects, always use the tongs and then place on an object, not directly on a gas. Now this is the product, the end product of evaporation, which, like I said, had been done hours before. Please note the color, that it was powdery and blue. Okay, so that we will use that result, or we'll use that comparison after we've done the next type of method. Now the last type of method we shall talk about is crystallization, dear learner. Crystallization is a process of obtaining a solute in the form of crystals from the solution. Please note that we want it in this texture of being crystalline. This is how we're going to do this. Dissolve the solute in the solvent to have the solution first, and then we gently heat. We gently heat the solution to evaporate, this time some of the solvents. Remember, in evaporation, we said we evaporate all of the solvents. In this instance, it's only some of the solvents, so that we are left with a saturated solution. What is the meaning of this term? This is whereby no more solid can dissolve in the solvent. It is saturated. Once we have a saturated solution, dear learner, we then remove it from the heat source and then we let it cool somewhere. Usually, we let it cool at standard room temperature to allow for large crystals to form. Note this, the longer you allow the crystals to remain, the bigger or the larger they become. For instance, if it takes 24 hours versus taking 3 days, then the ones which took 3 days to form will be even larger. We can take this a step further by saying, to get pure and dry crystals, this will be done in topics to come, acids, bases, and salts. To get pure dry crystals, you can then rinse this with distilled water. You filter off the solvent and then you dry it between filter paper, and hence you have pure dry crystals. General notes on this, we are saying crystals are produced in slow crystallization, and these are bigger in size compared to the ones that are produced from evaporation, which we also term fast crystallization. Let us do this short exercise. Describe how evaporation and crystallization are used during the production of brown sugar from sugarcane, the production of salt from seawater. The response, dear learner, was saying, you know salt, you know sugar. These are in crystalline forms, right? So it means this requires slow crystallization. But when you describe this, you need to take us through the steps. You need to mention that before we continue, before we get the crystals, we first have to get that saturated sugar solution from the sugar cane. We have to get that saturated salt solution from the seawater. Once those are saturated from heating, of course, you can then let them cool. And then once they cool, that is when the crystals will start forming. Remember, when you talk of crystallization, always mention that upon gently heating, there should be a saturated solution. Always mention that then there needs to be cooling of that saturated solution before crystals can then form. This is a diagram to show crystallization. Step 1, of course, shows when they are making up the solution. Step 2 is the one that I'm mainly interested in. We have an evaporating dish, so you'll see that this is basically the same setup as evaporation. Having said that, this is slow crystallization and evaporation is actually fast. So here we are gently heating, remember, until we leave only a few molecules of the solvent. We do not heat out everything. And once we have the saturated solution, we then let it cool so that crystals can then form. Should you want to have pure and dry crystals, then you can do the adding of distilled water, rinsing with distilled water, filtering off the solvent, and then drying between filter paper. To illustrate crystallization, let us watch a short video again, dear learner. This is now crystallization. We'll start off where we had a filtrate from copper sulfate and sand filtration. We transfer it to an evaporating dish, place it on top of a wire gauze which is on a tripod stand. Remember to adjust your flame, dear learner. And then now we want to gently heat so that only some of the solvent is evaporated. Remember, crystallization or slow crystallization is about getting the solute in a texture of crystalline form. So we need to be careful that we do not heat or we do not evaporate all of the solvent. So just like the previous ones, we're done some of the, so we have a product of crystallization already made the night before. Remember the etiquette: do not touch hot objects with your bare hands. Always use tongs and then place on a heat-proof object. So there is once we have this, remember it's now a saturated solution. What are we supposed to do? Remember the next step is to cool, and I said preferable at room temperature. So we're now taking the evaporating dish with our saturated solution and we're leaving it on the next to the window. We'll check on this crystal, on these crystals over some few hours. It may take even days at times, but I prepared some for you. So these are the results of slow crystallization. Please note the color as well as the size of this if we compare to evaporation, which we are from. Now let me take the evaporation product and then please try to compare. This one looks powdery and is light blue. In the other one, which is low crystallization, dark and crystals which have a definite shape. So that tells us that from crystallization we are able to get a certain type of property that we require. In summary, dear listener, dear learner, we are saying we have described filtration as a separating technique whereby we're separating a mixture of an insoluble solid from a liquid. Remember, we identified the filtrate, the filter paper, the filter funnel, as well as the residue. We said evaporation is a technique whereby we are separating a solid from the solution without keeping any of the solvent. Whereas in crystallization, we said we are separating the solid as crystals from the solution, and hence we had said there are two types of crystallization: slow and fast crystallization. And of note, we said fast crystallization produces small crystals, while slow crystallization gives us larger crystals. Now let's go over some work. So we are given two situations and they're asking us which techniques are best suitable. A, to obtain pure sodium chloride crystals from a solution. I think that's a telltale already that they have said crystals. It already should click in your mind that this is crystallization. You want a solid in a crystal form. And then B, to obtain sugar from a mixture of sand and sugar. Light bulb, sand and sugar. There was no mentioning of any solution this time. So what does that mean? Before you continue, add water, because you should be able to note that one of the solids is an insoluble one and the other is a soluble one. When I add water, the sugar will dissolve, the sand will not. So from then onwards, I can do filtration to remove the sand as the residue, and then crystallization to get the sugar crystals. If I want to get even bigger ones, I let them stay for much longer. And then another question is, students react a solution with dilute hydrochloric acid until a neutral solution is formed. Describe how they can obtain crystals from a neutral solution. It's 2 marks. So we definitely want to see that there's gently heating which will result in a saturated solution. And we also want to see you mentioning that after that you remove and you cool this for crystals to form. Saturation should be there. Crystal cooling should be there. And then the last question, she then adds sodium hydroxide and white precipitate is formed. A white precipitate is an insoluble solid, so this requires filtration. Be careful with your with your drawings, they should be large, they should be precise, they should be realistic. Do not draw things with overlapping lines. Never do that. And the last question, what is one precaution that you can take? Wear proper gear, use clean glassware. Any of those, wear goggles. Any of those for 1 mark. Thank you, dear Lena. We've come to the end of our lesson. I hope you enjoyed today's lesson. And let's see each other in the next ones to follow.
Yes, let's see each other in the next lessons to follow. Thank you very much, Tobile, for that. And we hope your students actually enjoyed it. Thank you so much. All right, viewers at home, please do not go anywhere. Lerato and myself will be right back after this. Welcome back to our viewers. Unfortunately, that was the last lesson for the day. I'm hoping you had a good day.
I had a good day, although it was very hot. How was your day for you today?
It was very, very hot. But I'm sure everyone is looking forward to the weekend. Today's a Friday. We have 2 days off. You guys have 2 days off to catch up on any lessons that you missed on our YouTube channel.
Yes, our YouTube channel, which is live from 2 p.m. until 5 p.m. And please do not forget to click that subscribe button so that whenever we are live, you get a notification.
Yes, of course. And a reminder that we are also live from 2 p.m. until 5 p.m. Mondays and Fridays on Facebook as well. And if you have any questions, please feel free to use the WhatsApp number.
Okay, now we'd like to get to the most exciting part of the day, which is the shout outs. So shout out to everyone who's been watching, shout out to my friends, shout out to my family, shout out to basically everyone that I know, and shout out to the best production team we are working with this week. Any shout outs?
Yes, most definitely. Shout out to the best production team that we work with. Thank you very much, guys, for making sure that we look proper, that we look we look beautiful. Thank you guys at home for watching. Thank you to our friends, to our families for watching and supporting us all the time. We will see you guys on Monday 2 p.m. sharp. Have a lovely weekend from us and the great team.
Bye. See you guys next week, guys. We love you guys. From us and the best production team. Quote that.
Bye.
Okay, bye, guys.